Part 1. Flame tests. This is for metal cations. Method and 4 steps for full marks. 1. Clean your nichrome wire in dilute HCl. 2. Dip in your sample. 3. Hold in a roaring Bunsen flame. That's the blue non-luminous one, not the yellow safety flame. 4. Observe the color. You must clean the wire. Why? To avoid contamination. That's a mark. The 5 you need to memorize. Lithium, Li+, crimson red. Sodium, Na+, yellow. Potassium, K+, at lilac. Calcium, Ca2+, orange red. Copper, Cu2+, blue-green or green. No color? That means no metal ion from that list. Think magnesium or aluminium. They give no color. Why does it work? Quick 6-marker answer. Heat excites the electrons. They jump to a higher energy level, then fall back down and emit light. Each metal has a unique emission spectrum, so unique color. Top exam trap. Flame tests are qualitative, not quantitative, and they are terrible for mixtures, especially if sodium is there. That yellow masks everything. Part 2. Gas tests. 4 gases, 4 phrases. Learn the praise, not just the idea. 1. Hydrogen H2. Test. Lit splint. Result squeaky pop. Why? 2H2 plus O2 yields 2H2O. Combustion. It's highly flammable, so be careful. 2. Oxygen O2. Test glowing splint. Result glowing splint relights. Not lights, relights. O2 supports combustion. 3. Carbon dioxide CO2. This is the most tested. Test. Bubble the gas through lime water. That's calcium hydroxide, Ca open parenthesis, OH close parenthesis 2. Result. Lime water turns cloudy or milky white. Equation you need, Ca open parenthesis, OH close parenthesis 2 plus CO, 2 yields CaCO 3 plus H2O. That white solid is calcium carbonate precipitate. Top tip. Examiners hate bubbles. You must say lime water turns cloudy. 4. Chlorine Cl2. Pale green gas, toxic. Use in a fume cupboard. Test damp litmus. Result bleaches white. It bleaches moist blue litmus to white. That bleaching property is unique. Part 3. Paper chromatography and RF values. This is a required practical and a maths question in one. Method 6 steps. 1. Draw a baseline in pencil. Why pencil? Pen would dissolve in the solvent and mess up your chromatogram. That's a mark. 2. Spot your inks or dyes on the baseline. 3. Place in a beaker with solvent, but solvent must be below the baseline. 4. Solvent rises by capillary action. 5. When it's almost at the top, mark the solvent front immediately. 6. Calculate RF equation. You need to memorize this. RF equals distance traveled by substance divided by distance traveled by solvent front. Example on the board, solvent front is 8 centimeters. Ink A travels 3 centimeters, so RF equals 3 divided by 8 equals 0.375. Key facts for full marks. RF is always between 0 and 1. It has no units. Same substance has the same RF in the same solvent. Larger RF equals more soluble in the solvent traveled further. Why does it work? Stationary phase is the paper. It holds things back. Mobile phase is the solvent. It carries things up. Different solubilities and attractions equals different distances. Purity test. This is a 2-marker. Pure substance equals 1 spot only. Impure or mixture equals multiple spots. Chromatography is used to identify substances and check purity. Exam tip. Always measure from the baseline, the origin, to the center of the spot, and from baseline to solvent front. Part 4. The big one. Testing for positive and negative ions. This covers everything else. Let's do cations first. The NaOH test. Add a few drops of sodium hydroxide, NaOH, to your sample solution, then add excess. General equation, M2 plus 2OH minus yields M open parenthesis OH close parenthesis 2. That's a precipitate. For aluminium, it's Al 3 plus 3, OH minus yields Al open parenthesis OH close parenthesis 3. Now the colors and say these exactly aluminium Al3+, or white precipitate, but with excess it dissolves to give a colorless solution because Al open parenthesis OH close parenthesis 3 is amphoteric. This is the only one that dissolves. Calcium Ca2+. White precipitate remains white, insoluble in excess. Magnesium, Mg2+, white precipitate, insoluble in excess. Copper, Cu2+, blue precipitate of copper hydroxide, remains blue, insoluble. Iron 2, Fe2+, green precipitate, and this is key. It turns brown at the surface as it oxidizes to iron 3. Iron 3, Fe3+, brown rust-colored precipitate, remains brown. Learn those 6 lines. They are guaranteed 3 to 4 marks. Now, anions, negative ions. First, carbonates, CO3 2-. Add dilute hydrochloric acid, HCl. You get effervescence fizzing, CO2 gas produced. Then bubble through lime water, turns cloudy milky white. We did that equation. Second, sulfates, SO4 2-. Step 1, critical. Acidify first with dilute HCl. Why? To remove carbonates and prevent a false positive. Then add barium chloride, BaCl2 solution, positive equals white precipitate of barium sulfate, BaSO4. Equation, Ba2++ SO4 2- yields BaSO4 solid, white precipitate insoluble in acid. Third, halides, Cl- Br- I-. Step 1. Acidify first with dilute nitric acid, HNO3, not HCl this time. Why? To remove carbonates and sulfates. Then add silver nitrate, AgNO3 solution. Equation, Ag++X- yields AgX solid Cl minus equals white precipitate, AgClBr minus equals cream precipitate, AgBri minus equals yellow precipitate, AgI bonus mark. AgCl is light sensitive, turns gray-purple in sunlight. Key facts, checklist for your last-minute revision. Always acidify first. Carbonates and sulfates with HCl. Halides with HNO3. Precipitate colors must be exact. Examiners want the words white, blue, green turns brown, brown, cream, yellow. Excess NaOH dissolves Al, open parenthesis, OH, close parenthesis 3, only. Lime water turns cloudy milky equals CO2 present. Pure equals 1 spot on chromatography. Ion tests are qualitative. They tell you what, not how much.